The 11th element on the periodic table of elements is sodium. This is Norris Teaches Science with me, Mr. Norris, another physical science edition video. Today we're going to talk about the actual periodic table, how it's structured and the arrangement of it. So by the end of the video, you should be able to say, I can discuss the setup and arrangement of the periodic table of elements. Now, before we begin, you need to make sure you have a printed version of the periodic table in front of you. You also are going to need 3 different colored pens, colored pencils, markers, something. Because at the end of the video, we are going to label it to help us complete other parts of this video section. And when we get into chemical bonding and writing formulas and names, it's going to be really important to have these labels. So pause real quick, get your materials, and then come right back. I am going to be using the colors red, the color green, and the color blue. But you can use whatever 3 different colors you would like to do. So, the periodic table, it's an arrangement of elements into columns. Columns go up and down based on repeating on properties that repeat row to row. Row goes across. So columns properties, they repeat as you go down. The modern periodic table was arranged by a guy named Henry Moseley, and he has arranged it by increasing atomic number, but it also relates to what family and groups they go into. That's the way it worked. Now, the parts of the periodic table, you have your rows. Your rows are called periods. Your rows are called periods, and they go across. Columns, which go up and down, we call them groups. So if I tell you, give you the element carbon, you can tell me what column it's in and what row it's in. All right, and that's what we're going to be able to do when we label the periodic table. So periods go across. Remember, periods go across. You can see the periods in different colors here. There are 7 periods, 7 rows currently. I know it looks like there would be 9, but these 2 down here actually go up just a little part. They did that so that the periodic table wasn't too long. Now, elements in the same period have the same number of energy levels or shells or orbitals. And basically, so if you're in the first period, the ones that I read, they only have 1 energy level. The second period, the second row, all have 2 energy levels. Go on and go forth. Groups, remember, are the columns, and they go up and down. You can see some of the groups here. We're going to ignore the middle of the periodic table in physical science. We're going to talk about them in general, but we won't be doing much with them. There are 18 groups, so there's 18 columns. Elements in the same group have things in common. One, they have the same properties. So all the ones that are purple on this picture all have the same properties, things that they do. They all are going to have the same number of valence electrons, and we're going to talk about what they are in a moment. They all have the same oxidation number, and we're going to talk about that in a moment. All right, speaking of valence electrons are the number of electrons on the outermost or the last energy level. I have the saying the number next to the A at the top of each column. In North Carolina, we have a periodic table that we use that the state gave out, and at the top of each column, they have a Roman numeral next to the letter A, because we only mess with the A's. The B's represent something else. And so that Roman numeral usually is the hint of what the number of valence electrons that group has. But we do have a code, and the code is 1, 2, 3, 4, 5, 6, 7, 8. And it's good to know that valence electrons code is this when we label the periodic table, which is coming up soon. So speaking of the Roman numerals, if you're in North Carolina, you do need to know your Roman numerals. And they're here. 1 I is 1, 2 I's is 2, 3 I's is 3, IV is 4, V is 5, VI is 6. If you notice the order between 4 and 6, there's a little difference. VII is 7, VIII is 8. If you're a big football fan, you would notice that Roman numerals are used with the Super Bowl, so it would be good to learn those, especially when the Super Bowl starts to get into high numbers. Oxidation numbers is another thing that everything in the same group have in common. They're the number of electrons an atom will gain or lose to become stable. All atoms want to become stable. And stable means that there is 8 electrons on the last shell or on the last energy level. 8. So if you don't have 8, your goal is to get 8. Usually if you're Usually, you can look at the oxidation number and tell if they're going to gain or lose electrons. The code for oxidation number is +1, +2, +3, plus or minus 4, -3, -2, -1, 0. 0 means it's stable. It doesn't want to gain electrons, doesn't want to lose electrons. It's already stable. It's not going to do anything. Now, these plus and minus signs give a little hint. Plus means you're going to lose electrons, because electrons are negative. So if you lose electrons, you become positive. So a +1 means that they're going to want to lose 1 electron to be stable. The minus sign means gain electrons. If you gain negative people, you become negative. So say this -3, they want to gain 3 electrons. The plus or minus 4 means you can either gain 4 or lose 4, whatever would be easiest. So let's label our periodic tables. Get your periodic table in front of you, get your 3 pens in front of you. I'm going to start with my red because I already have it here. And when I label my periodic table, I like to make a little key. So I'm going to do a little squiggle with my red, and my red is going to represent my valence electrons. All right, so we're going to label our valence electrons. Now, in physical science in North Carolina, we do not label the middle of the periodic table. So all of this won't get labeled. So if you remember our code, valence electrons code is 1, 2, 3, 4, 5, 6, 7, 8. So I go 1, 2, skip the whole middle, 3, 4, 5, 6, 7, 8. All right, let's switch colors now. Coming over here, I'm going to get my blue. All right, do a little my squiggle with my blue, and my blue is going to represent my oxidation numbers. You notice I do a little shorthand here because I know what these symbols mean. You may want to write the words out. All right, so the oxidation numbers, those are the number of electrons an atom will gain or lose, become stable. The code was +1, +2, +3, plus or minus 4, -3, -2, -1, 0. I know I say it really fast. I've done this for years, but this is why we labeled the periodic table. So over here, starting with where we wrote 1, above 1 in red, above it I'm going to write +1, +2, +3, plus or minus 4, -3, -2, -1, 0. All right, get your last color. Remember my last color I'm going to have is green, and I'm going to do a little squiggle. You're probably like, what are we going to label with the green? We're going to label the period. All right, so periods go across, left to right. We go 1, 2, 3, 4, 5, 6, 7, and then when we come down here, we repeat 6, 7. All right. Remember, periods tell how many energy levels there are. All right. I'm going to get the highlighter real quick, and I'm going to highlight with this color. So I want everyone to look at sulfur. Sulfur is right here. What period is sulfur in? Well, to find periods, we label them, so we're going to follow over until we get there, and we notice that sulfur is in the third period. Looking back at sulfur, how many valence electrons does sulfur have? Remember, our valence electron color is red, so we follow it up, and we see that the red number is 6. So sulfur has 6 valence electrons. Let's do this one more time. All right, sulfur, how many oxidation number? What is its oxidation number? Well, oxidation number is written in blue. Follow up, it's -2. Let's do one more. All right, I'm going to highlight it in purple. All right. All right, pause real quick, try to figure out the period, the valence electrons, and oxidation numbers. All right, carbon, it's in the second period. It has 4 valence electrons, and it has plus or minus 4 for its oxidation number. I really hope you learned something today. Make sure you've labeled that periodic table. Make sure you keep that label one with you. Come back for more videos. Make sure you bring the periodic table with you. And I'm Mr. Norris, and I'm out for this video.